Section 9.7 is the cross product. So if you have two vectors here in 3 dimensions, then we can take the cross product between them, which we denote with the x in the middle, as opposed to the dot product has the dot in the middle. So unlike scalar multiplication, where the cross and the dot mean the same thing, for vectors, the dot and the cross mean two different things. The cross product is sometimes called the vector product because you end up with a vector. Unlike the dot product, where you ended up with a one number, a cross product, you actually end up with a vector. Here's a formula for the cross product. In a couple slides, I'm going to show you another method to doing the cross product if you don't want to memorize this formula. So what the cross product means, when you find the vector that's the cross product of two vectors, that's perpendicular to both the vectors. So if we have A and B, and you find A cross B, then that's going to be perpendicular to both A and B. The magnitude of this cross product is actually the area of a parallelogram formed by those two vectors. The way that you calculate a cross product is either memorizing this formula, but what this formula comes from is actually a 3 by 3 determinant. The first row is just ijk. The second row is whichever vector is listed first, so in this case the coefficients of vector v, and the third row is whichever vector is listed second, or in this case the coefficients of vector w. This down here is finding determinants by minors, or we can just use the shortcut that we learned in section 10.4. Rewrite the first two rows and then multiply down on the down diagonals, adding those together, and then subtract multiplying up on the up diagonals. So if we want to find the cross product v cross w, given this v and w, first thing we need to do is set up our 3 by 3 determinant. So go ahead and pause the video and set up that determinant. So the first row should just be ijk. The second row is the coefficients of vector v because that one's listed first, so -1, 3, 2. And the third row is the coefficients of vector w, 3, -2, -1. So go ahead and pause the video and find this determinant. So if you multiply down, you end up with -3i hat plus 6j hat plus 2k hat. And then you're going to subtract 9k hat minus 4i hat plus 1j hat. I distribute this negative through and you end up with I hat plus 5j hat minus 7k hat. Now instead of v cross w, we want w cross v. So go ahead and pause the video and find w cross v. So if you do the same thing, except for now w is going to be in the second row and v is going to be in the third row, you end up with -I hat minus 5j hat plus 7k hat. What you might notice is the negative of v cross w. So that's a property. V cross w is the opposite of w cross v. So now try this one. Try v cross itself, v cross v. So if you end up with v cross v, the v coefficients go in both the second and third rows. So you end up with the same thing both directions. So everything ends up canceling out, and so you just end up with the 0 vector. So here are some properties of cross products. We talked about a couple of these. I would pause the video and write these down. So we talked about this one. Any vector cross itself we just found is end up being the 0 vector. U cross v is going to be the opposite of v cross u. If you have a scalar multiplied by a cross product, then you can multiply that scalar by either of the vectors, but just one of them. So a times u cross v is the same thing as a times u cross v or u times a cross v. And then you can also distribute a cross product, so u cross v plus w is the same thing as u cross v plus u cross w. So you could use these properties, if you've done one cross product already, you could use these properties to help you find other cross products with only having to do one determinant. So use the properties from the previous page to go ahead and find the cross product w cross v. So w cross w, anything cross itself is 0, so you end up with the 0 vector cross v. Everything in the second row is going to be 0, which means everything is going to 0 out, and you're going to end up with just the 0 vector. Here are some geometric properties of cross products. I would pause the video and write these down. So we talked about a couple of these a couple slides ago. So u cross v is perpendicular to both u and v. We remember that orthogonal is the same thing as perpendicular. Down here we're talking about some magnitude. So the magnitude of u cross v is equal to the magnitude of u times the magnitude of v times the sine of theta, where theta is the angle between the vectors. The magnitude of u cross v is the area of the parallelogram spaced by those vectors. And if two vectors have a cross product of 0, that means those two vectors are parallel. So now we're given 3 points, 3 vertices of a parallelogram, and we want to use those to help us find the area of the parallelogram. And we can do this using vectors. So I'm making vector A be the vector from point P1, or the origin, to P2. So that means it's vector 2, 3, 1, or 2i hat, 3j hat, plus k hat. I'm making vector B be the vector from point P1 to P3, or the origin to P3. So that ends up being the vector negative 2, 4, 1, or negative 2i hat plus 4j hat plus k hat. So now the area of the parallelogram is the magnitude of vector A times B, or A cross B. So go ahead and pause the video and find the cross product A cross B. So I set up the cross product with vectors A and B, with A being in the second row because it's the first vector listed. So you do A cross B and you end up with negative I hat minus 4j hat plus 14k hat. So that's this vector that's coming out perpendicular to both A and B. So to find the area, you need to find the magnitude of that. So go ahead and pause the video and find the magnitude of this new vector. So using three-dimensional Pythagorean theorem, you end up with negative 1 quantity squared plus negative 4 quantity squared plus 14 quantity squared, square root of all that. So the area of this parallelogram is the square root of 213 units squared. So remember, a cross product is a new vector that is perpendicular to both of the given vectors, and the way that you find that vector is by taking a 3 by 3 determinant, with the first row being I, j, and k, and the next two rows being the two given vectors.